the derivative in context. Okay, so this question says, hey, use the data in the table to estimate the first derivative at 6. So this is the t, the time. So at time equals 6, so we're going to estimate it. We're not going to go like 2 to 10. We're going to go right here and use this data to estimate it. When we estimate, we use the AROC. So remember, it says estimate, and that means AROC, which is just the slope equation. So h prime at 6 is approximately h of 7 minus h of 5 over 7 minus 5. And what does that give us? This is h of 7 is 11 minus 6 over 2. That's Nick. So 11, so that is 5 over 2. And don't forget our units. So to be sure we figure out our units, let's look what we're graphing. We are graphing, this is time, and this is height at time. So time is in years, and height is in meters. This is the t, which is like the x, and this is the h of t, which is like the y. And don't forget, again, AROC is just slope, the regular old slope equation, which is change in y over change in x. And so the y is going to be meters, and the x is years. So you don't have to do this chart, but if you're ever confused, like, what are my units, you could do that. So it's just meters here and years here. So it's 5 over 2 meters per year. So now that we have estimated it, we want to interpret the meaning of H6 and the context of the problem. So basically, what the heck are we actually talking about? Now, don't forget our famous little mnemonic, which is noun, unit, time. And this will just help you guys not to forget things. A lot of people forgot the time last time. So let's first go identify the noun. In this problem, we're actually talking about the height of the tree. So that is going to be our noun. The height of the tree is going to be our noun. And we already know our units right here. And then our time. Our time is already here. So all we have to do is put it together. And don't forget, they're asking us to interpret the meaning. So we also have to talk about what we've found. Remember, whenever we talk about a derivative, we're talking about finding the rate. So we want to include the rate, and we want to talk about if the rate is increasing, and that's if we have a positive value, or if we get a negative value, that means the rate is decreasing. All right, so let's put it all together. So our justification, or our context in this case, is going to be the height of the tree okay, so that's our noun, now we're not doing our units yet because we're going to talk about what's happening in the tree. The height of the tree is increasing at a rate. So increasing at a rate of, and here we put our answer in our units, 5 over 2 meters per year at, so this is our U, our units, at time t equals 6. And you don't have to put t 6 years, you can put t equals 6. But this is really important because remember, this is an instantaneous rate of change. So this rate that you have, we have this rate right here. This is the rate that we've approximated at time is 6. However, if time was different, the rate would be different. So that's why this is so important, the last thing, which is the t. So the N, the U, the t. All right, guys, have a great night, and let me know if you have any questions.